This lecture follows on from the Cisco troubleshooting methodology, and here we're going to have a look at how to do some connectivity troubleshooting using the commands ping, traceroute, and telnet. So the scenario we have here is we've got the network topology over on the right, and there is a user on a PC which is behind the R1 router, and he's complained that DNS isn't working. And in the example, the DNS server is our R3 router. Okay, so first thing to do, real world, whenever a user reports a problem, is don't believe them, check it first. I have spent hours troubleshooting problems that turned out not even to be a problem at all. The thing was actually working, it was just that the user was making a mistake, maybe a typo or something like that. So let's verify if DNS is working or not. So on R1, I'm going to ping R3 by its hostname. So I'll enter the command ping R3. And I can see that my domain server is 10.10.30.1, which is R3, so that's good, but it says unrecognized host or address or protocol not running. So we do have an issue here, DNS is not working. So if we suspected this was an IP connectivity issue, the next thing that we would do is do a ping from the source to the destination. So on R1, I'm going to ping 10.10.30.1. So I'll ping it by its IP address. This takes DNS out of the equation. And I can see that the ping is failing, it is unreachable. So I've got some kind of connectivity issue between R1 and R3. Now what I could do now is I could go hop by hop checking to see where the problem is. So I could check that R1 has got connectivity to R2, then R2 has got connectivity to R3, and so on. But a command I can use that will save a bit of time sometimes is traceroute. So I'm going to traceroute to 10.10.30.1. Now, what the traceroute command does is it does a ping, but it sends the ping with a time to live value of 1 and then 2 and then 3 and then so on. So because the time to live is set to a low value, if a router sees a packet and the time to live gets down to 0, then the router will drop that packet. It's a loop prevention mechanism. And we can leverage that with traceroute by sending the first ping with a time to live of 1. So it will get to the first router. Then it will send a time to live of 2. It will get to the second router. Then a TTL of 3 and so on. So what this does is it maps out the path from the source to the destination from end to end. And if there is a break in the connectivity somewhere along that path, then the traceroute should get as far as that router. So it helps us identify which router the problem is on. So let's try the traceroute, and we can see that the first hop, it's getting to R2 on 10.10.10.2, and then that's as far as it got. So the final router it got to was R2, so the problem is most likely there. So let's just jump straight onto R2 and see what we can see on there. Okay, so here I am on R2. On R2, I'm going to ping R3 on 10.10.30.1. And this ping I can see is failing. So the next thing I'm going to do is R2 does not have an interface directly connected to the 10.10.30 network, so it would need a route to get there. Don't worry about routing too much now because we're going to cover that in a later section. But for now, I can check the routing table with the show IP route command. So I do this and I can see that yes, there is no route to 10.10.30. So I'm going to fix that. So I'll enter the command config T to get to global configuration, and the command to enter a static route is IP route, then the network I want to get to, which is 10.10.30.0. The subnet mask is 255.255.255.0, and the next hop address to get there, which I need to have an interface that's on the same subnet, is 10.10.20.1 on R3. So I'll try that and then end to get back to the enable prompt, and I'll ping 10.10.30.1 again, and I can see that the ping is successful. So if I now go back onto R1, then hopefully the ping will work okay from here too. So here's me back on R1. I'll ping 10.10.30.1, and the ping is successful now, so I fixed my connectivity problem. Okay, so that was a demonstration of how to use ping and traceroute. The other command we can use here is telnet. So ping and traceroute will troubleshoot layer 3 problems. You can use telnet to help with layer 4 and above problems. What telnet you can do with it is you can telnet to a particular port. So from R1, I'm going to telnet to 10.10.30.1, and I'm going to telnet to port 53, which is the DNS port, and this should tell me if DNS is running on R3 or not. And there I can see that port 53 is open, so R3 is running DNS. So that looks good. Just to double check this, I'll check DNS is working. I will ping R3 by its hostname, and I can see that it resolved it to 10.10.30.1, and the ping worked. When I did the telnet, if it did not see the port as being open, then that would indicate that the service is not running on that particular destination. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.